picking up where we left off. We have the build Makefile working. In fact, let's do that. Let's clean this up. So I'm gonna minimize this for now. I'm gonna make this window a little larger so we have more space, and I'm gonna make this one taller for the same very reason. Let's fit them nicely side by side. And what I'm gonna do first, I'm gonna create a baseline, so to speak, right? So let's refresh F5 and Control B for the build. While it's building, I'm gonna close Visual Studio because we are not gonna be needing that today yet. Plus, I think there is a Windows update coming up, so it's gonna be a reboot anyway. Once this build is done, we have the directory profile release, which I'm gonna rename into orig, and we're gonna do our cs make, which is going to fail because we don't have the directory, and this is the first thing we're gonna tackle. You see, this profile release directory is not here, and that's why it's failing. So for that, what we are going to do, before we do that, let's get rid of this include makefile init, because I believe it's just a single line. Yeah, it's a single line. There is no reason to include the whole file. We'll just minimize the dependencies by copying it here, removing this. So for the creation of the directory, what we are going to do in both of assembly and the C file, we're gonna do the dir guard dig directory guard macro. I want it to be silent, and what I'm gonna be doing is now we need to define that. It's gonna be defined as dir guard is going to be a makefile Windows command, which is going to create a directory. The directory that we're gonna be getting is an automatic variable from the build rule itself. However, it is very sensitive to forward and backward slashes. So what we need to do is we need to do a substitution, for which we are going to do the subst all the forward slashes with backward slashes inside this guy. And just to be on a safe side, let's take care of the spaces that may be embedded. So we're gonna put it into double quotes as far as the makefile is concerned. Now we don't want the standard output to clutter our screen. And also what we're going to do is we are going to redirect the error output into standard output, effectively shutting down both of them. And the last thing we do, we can just make sure that the command always succeeds. This is essentially a shortcut for or true, but this is shorter and cuter. And I just realized that when I select text, it's not very visible. Let me change the settings quickly. Style configurator. Let me go ahead and go to selected text output, change this into something more noticeable. I don't know if that's too... oh, that... oh, this is good. I like it. Save and close. Okay, so now when I select text, yeah, it's gonna be visible. Good. So with that change, let's save Ctrl S, we should be able to actually run it successfully, because it should create... there we go, profile release. Fantastic. Next, as we are working with this build script, what I want to do is to make sure that the file we produce is still the same, no differences encountered. For that, let me select this line over here and add it into the post build. There we go. Again, Windows is sensitive to backslashes and forward slashes, although in this particular case it is correct backslash because I just copied it, right? So now when I do the make all cs make all, nothing to be done, right? That's another thing. What I also want to do is anytime I change the makefile, I want that to force the rebuild. So both makefile, both the assembly and the C file compilation, I want both of them to depend on our makefile. Now if I do cs make all, it should trigger the recompile. Fantastic. And it should also at the end check that our build produce the same binary as the other, as our baseline. Good. Now don't repeat yourself is a wonderful tool that I try to live by, and with that in mind you can notice that this much is repeated here, here, and also in the linker. Let's extract that into a variable which we will call common flags, right? Common flags is coming up here. Common flags equals to this much. And now all the occurrences of this long string I can replace with this and this. Good. Next we will also note that, let me rearrange a few things here because as we look into things being displayed, let me put libraries and the dependencies up a little bit over here before the flags, so that I have the target for the linker near us. And let's extract the variables for the linker as well, and likely for assembly and for the C file compilation. Let's do that. So extracting this much, which is going to be called assembly flags, right? It makes sense, I hope. Assembly flags is gonna be that, and this is clearly going to be CC flags, of course. So CC flags, need to remember to have it here. Flags equals what we just deleted from there, and also we're gonna have LD flags, which is going to be a whole bunch of stuff from here. That's a lot, all the way to dash O, right? LD flags. Let's go up here and put it in here. Okay, let's verify that our build is still producing the right thing, which it does. It's building. Next thing we notice is the use of this path to where our toolset is. Let's see if we can replace it with something more usable, which would be FX3 install path, this one right here. So this much can be, let me control F3 so I find it next as well. Let me replace that with this FX3 install path. Copy here, F3 for next occurrence, paste, F3 for next occurrence, paste, F3, paste, F3. This one is going to be with the ARM GCC, so we will handle it later. This one is also ARM GCC. Okay, so we only have ARM GCCs left. For ARM GCC, it's right here, ARM GCC install path. Copy with the enter, go in here and putting it here. Now let's copy and push it here. And one more thing you may have noticed is this 481, which is right here, ARM-GCC version. Let's select, enter for the copy, and put it here. Okay, so not repeating yourself would be nice if we also can look. Yes, if you look at this much, it really does look very similar, except for this, I suppose. So let's rearrange it a little bit, and this and that can probably be extracted into common flag set as well. So that's for the compilation, right? So let's just call it compile flags, this much, and this will be compile flags. Also, just to make sure, let me control F3 from here. Yep, that's exactly the same thing. Compiler flags, which, you know what, they should just include common flags. Yeah, because it's, again, don't repeat yourself, the dry principle. There we go. So this can now be moved into here, and this is going to be compile flags, and this can be removed to that much. Let's make sure that our build, let's do the clean and then do all. I'm sure it's gonna be fine. Next, what we are going for, so if you take a look at our build, it's already much cleaner. You can see that it's LD flags and target dir. So let's handle this. You see it's repeated all over the place. So let us copy this and let's have it, remember it over here. We'll call it target name, right? And it's gonna be a constant, more or less, so I can use the Pascal style colon equal, which is different from equal in the way that when the target directory is being used, because it's an equal sign, it's a lazy evaluation. So if there was anything to expand over here, like any variables, for example, right, the expansion would not happen until it's being used. If, however, I do it like that, then the expansion happens immediately, and if I change the value of temp later on, it will not affect the value of the target dir. For now, we're gonna keep it this way, but this is more or less constant, so there is no reason to overthink it. We can just have it with the colon equal. Now let's replace all of the occurrences of this guy with target name, except the first one. That's why I'm not doing the replace all, because I need to target only these occurrences. So copy, F3, paste, F3, paste, F3, paste, F3, paste, F3, F3. Okay. And now we only have it over here, which again, it just unifies things. So whenever we want to change the name of our output target name, we just change it in one place, and it triggers trickles down automatically. Next is, let's just do a short, quick little thing, is the erasure. Well, first of all, I don't like this echo, it's the end, which manifests itself like this. I don't like it. Let me remove this. So this RM over here, it relies on csrm, which is nothing wrong with that, but our final goal is to remove the dependency from the Cypress build toolchain. So this is part of it. Let's tackle it right now. And the way we're gonna do it is by using the Windows command called erase, which has these parameters. So we're gonna need the subdirectories, and we're gonna make it quiet, right? So let us erase /s/q, And as far as target dir is concerned, we need to replace potential forward slashes with back slashes, which we already know how to do. We are going to also put it into quotes, double quotes, so we are not plagued by the usage of spaces embedded into the path name. So what we do is substitute all the forward slashes with backward slashes for whatever is in this target directory. Close. So what this should do is it should remove all the files. So cs make clean invalid match. Oh, right, I just said forward slashes, backward slashes. Important thing. Make clean. Okay, deleted files. It wasn't very quiet, was it? So let's do the same thing we did for the dir guard. We want to redirect the output into null, and also the errors, I suppose, as well, into the standard output, and we can make the command always succeed this way, so it doesn't fail the build if it cannot do it. Now what we should end up having is an empty, folder is empty. And if we do cs make all, and let's make it with the J6, so it's slightly faster. This virtual machine has 8 CPUs, so it should handle it with no issue. And what we have here is the output. We also produce the file which matches our baseline, which is good. Next, let's take care of these things. So C sources are being manually put into here, which is not what we want, and also the assembly source files. So what we want to do is to generate a unified list of all the sources by extension. Let's have an extension list which would be source ext, and what we want here are the S and the C files, and eventually we can add CPP files into here, right? With that said, what we can do, where will we do that? Let's start, we can do it here, so we can remove it as we go. So the sources can now be evaluated as using the for each. So for each extension in our list of source extensions, what we want to do is we want to get a file using the wildcard of start.that extension, right? ext. Whether it's doing the right thing or not, I don't know, so let's verify. Let's use the info, that's kind of a printf, list of sources is, and I'm gonna put it into brackets, so if it fails we will see an empty string here, just a little nuanced thingy. So now if we run the make cs make, it should produce the list of source files, and you can see it right here. Although it did fail, why did it fail? What did we do? How did we screw it up? Let's quickly roll back and see if that is what caused it. No, something else caused it. What did we change recently? Control Z, Control Z. Let me revert source extensions, erase. No, all that was fine. So why are we having this issue over here? Oh, right, because I do need to specify the all. That would help. That definitely helps. Coming back here, it did produce the correct list of source files, right? So these are all the files that are in our current directory that we want to build. works fine. Next we need the list of object files. Object files are going to be evaluated by a very simple substitution. So we're going to take the sources and we take the file, and we're gonna have that file with an extension O, and we also want to put it into the target directory. So that is target dir in our case, and slash. Now that list can be used now to produce the dependency files. Dependencies are all the way over here. Let me just move it up a little bit, because we're gonna get rid of other things. So we are going to get rid of the S upper dependencies. We are never going to be using them. We can remove the sources, the objects, the dependencies, all of that. The assembly will also not be doing any assembly builds, and the dependencies are going to be generated using another very simple substitution, which is to take the list of object files and just replace their extension, whichever was O, with a D. And the reason we are going by the object files is because if we have the same file name without the extension for the assembly file and for the C file, we need to distinguish them somehow, which is why over here when we were saying object files, we would just append the .o extension instead of replacing it, so that we have in the result .s.o file and .c.o file, which also means that when we are building these files, we need to make sure that we know what we are building, .s or .c.o files. Now going for the dependencies, now we're gonna have a dependency file which is named .s.o.d, and .c.d. Now what we have here is we need to compare, we need to figure out if the list is empty or not, and if it is not empty, we include it. And also we only do it if we are invoking make with not a clean, with anything else but the clean. Let's clean up a little bit here. This is not being used, so let me remove that. These are all, maybe not all, let me go one by one. This one is not being used. Control F3, this one is not being used. Control F3, this one is not being used. Control F3, this one is not being used. This one is not being used. The object files is created here. C dependencies is no longer used because we are using the automatic generator of the dependencies list. Okay, so what we have here is the list of sources, which is based on extensions. We have a list of object files, which is based on sources, and we have a list of dependencies, which has been included, so we can track whether header file is changed or not. Now we have libraries, we have our flags, we also have we are gonna take care of this next. So let's make sure that the build is still good. So make all J6 seems to be going fine. Now that ARM non EABI GCC, where is this coming from? So of course I want to have it over here, which is this, but I don't want to rely on some random path. So let me figure out, no, not where, not set, where is this coming from? This is coming from ARM GCC bin ARM non ABI blah blah blah. So this is over here, this guy. Let's copy that, let's put it in here, and of course we want to do double quotes for the embedded spaces and all that. So this bin ARM non ABI, and now what we can do is we can replace these guys with invocation of the tool. So whenever we change the tool set, we only change it in one place and it affects everything else. Convenience. We could have had the same for LD, but since we're using the same one, for now it's fine. Let's make sure that we're still good. Not that. Yes, make all J6. Fine. What else is left for us to do in here to make it good for today? User objects. I don't think it's being used. Yeah, it's empty. So let's just remove that altogether. Removing this. Clean up, clean up, clean up, clean up, clean up. Target directory. You know what? Let's have a target directory starting with the build. And the reason for that is that next time we continue working on a makefile, we want our makefiles produced by the Visual Studio to all go into build and to subdirectories of the build, where we will have profile release, release debug, profile debug, and then they will not be clashing with similar builds of the Cypress FX3 build system, so we can compare the output files and make sure that our binaries match completely and we are not ruining things. Also, as you can notice, this target dir is the only thing we need to update now. Let me save. For the build to end up going into a new directory, which I hope, yeah, there we go, build, and inside build there is a profile release, and this is exactly what we want to happen. Now we can remove this one as not needed. I will temporarily, at least until next time, disable this check, which we'll come back to later on, because it's not going to be orig, it's going to be the target name basically. And one short, let's do a quick review of what we have done so far. We got rid of the extra file which is making it. Let me get rid of it here, delete, so that in here it will show up as removed file. Also, I probably want to remove this release org, of course, and here it now shows as makefile init being removed. Next, we set up our CC tool to point to where our build invocation is. We also have a directory guard. You know what, I'm gonna push it a little bit. No, it was a good place for it. Fine. It's like one of the pre-initialized things. The dir guard is taking care of creating directories if they don't exist, so our build doesn't fail. The target directory is being set up, the target name, and the difference between colon, equal, and equal is if it was to use any sort of variables in here, they would expand lazily when it's being used, when it's just a simple equal sign. But if it's colon equal, then there is no expansion happening, it just happens here once and it's like a const basically. Then we have a list of extensions that we care about, which we'll add CPP to later, which is used to produce the list of sources by using the wildcard function. After which, based on that, we say that our object files are going to go into our target directory and we'll have the extension .o in addition to the regular text file extension .s or .c. Then if it is not a clean, we generate a list of dependency files by replacing .o with the .d, and if this list is not empty, we include it into dependencies list. We did not touch the libs because it's fine, no reason to touch it. We do have compiler flags. We can probably colon equal this one, but these ones cannot be colon equaled because they do require lazy evaluation later on for this part. Same goes for this one, it cannot be colon equaled because of this part, which is going to rely on expansion during evaluation. We have our LD flags. Same story, I believe we have. No, we don't have any expansion here, so technically speaking we should be able to do that with no issues. Let me build just to make sure. Fine, it built. Although I think no, it's in the build directory, which is part of our ignore.gitignore file, so whatever build happened, it's not getting to be part of our repository. Next, what we have is we updated the compilation of assembly and C files by making them dependent on makefile changes. So anytime we change a makefile, it will trigger the rebuild of these. And we also made sure that the list of the files is properly .odd after the original extension, which will also help us later on when we have CPPs, which will have slightly different build flags. So we will have a similar .cpp.o rule. This we don't need. This is fine. This is fine. Everything else is okay, and we are ready to check it in. Why not? So this is now season 1 episode 5, which is hand rolling makefile. I suppose that's good. A lot of changes, not gonna look into them because we verified them with the build. Let's commit to main. Let's push to origin, and I'm pretty sure, let's close this, that we're gonna do the Windows update anyway. Always exit without prompt. Yes, I do want that. This one is not needed. This one we can exit. And yes, there is something going on here which says that we are going to come to a brand new Windows next time I start the next episode. With which I say thank you for watching and see you in the next video.